project aims to do is to design an efficient framework for volumetric brain tumor segmentation and classification using context-aware point sampling and deep learning techniques. Now, when it comes to brain tumors, the first and foremost thing in the treatment is to define the region or annotate the region defined by the tumor, right? But the issue with that is traditionally a radiologist would have to manually segment through and annotate through the tumor defined region, and that takes hours and hours. So that's not very time efficient. And the issue with current ML methods with doing that is this slice based. Now, typically, this is what an MRI volume would look like. You can see every single image over here is called the slice. And all these slices, when put next to each other, they constitute an MRI volume, right? A complete brain tumor. But the issue with slice-based methods is that, firstly, since there are hundreds of slices, you have to go through every single slice over and over again. So that is very time-consuming. And second, it can't produce a true volumetric output since it's two-dimensional based. Now, to combat that, I have introduced this project. And what this aims to do is to first off define a saliency attention network, which basically creates an attention map of where the tumor is most likely of being present. And secondly, it can run voxel-based segmentation. Now, the benefits of that is that first off, since it's voxel-based, it can obviously create a completely true volumetric representation, a 3D representation. And secondly, it requires only one-time inference. So instead of running through hundreds and hundreds of images, it can do that a single time, and that's much more time efficient than current models. And this is what the final output would look like. As for future scalability, I plan on training this on other tumors. The dataset that I've used to train this model currently was the BRATS dataset from the University of Pennsylvania. That was on an 80-20 training to validation split. And the accuracy methods and metrics, as you can see, are over here. And that was my project. Thank you.